Hey, what's up everybody? This is going to be lesson 2 of unit 2. Again, unit 2, we're focusing on the foundations of geometry. In lesson 2, we're going to talk about congruence, midpoints, and distance. After this lesson, you should be able to know, interpret, understand, and use congruent symbols when we use them to mark figures. And then you also should be able to calculate using midpoints and distance given 2 points. Now, just to kind of break it down real fast for you, this is the symbol of congruence right here. So the symbol of congruence is an equal sign with the tilde above it. This symbol means that two different things are the exact same measure. So we could have two lines that are the same length. That means they're congruent segment lines, or congruent segments. We could have two angles that are the same measure, or two 60-degree angles that would be congruent. So it would follow this signage here. Now, if we look at two triangles here, when two angles are congruent, they are marked with the same number of arcs here. So we know that angle A and angle D are congruent to each other because they both have this one arc mark. Angle B has two arc marks, angle E has two arc marks. That means that these two angles are the same, which means they'd both be equal. So if angle B was 30 degrees, angle E would be 30 degrees. Now, when we talk about congruent lines, we use these little tick marks. So if AB and DE both have the same number of tick marks, both have 1, that means that they're both the same length. So this is just a basic understanding of what congruence is. We're going to get into it a little bit more here. Oops. Now, in the second video that I'm going to do, we're going to talk about how midpoints are formed. So midpoint, you could probably interpret it or guess it that it's the middle point in between two other points. So in this case, the midpoint B, if it's the midpoint, it's the same distance from A as it is from C. Or if we want to use congruence, we could say that the length of AB is going to be the same as B to C. So they're congruent. And that's because B is the middle point. It's in the middle between two other points. And then we're also going to look at distance formula. Whenever we want 2 points on the coordinate plane and we want to figure out the distance between them or how long like this green line is, we can use this distance formula, and that's what we're going to talk about in video 3. All right, so let's get started on congruence. So congruence in non-math terms means that two things are in agreement, or they correspond with each other, or they're similarly related. An example in a sentence would be that their goals are not congruent with the goals of the team. That means that an individual's goals are a little bit different than the team, which isn't necessarily a good thing if you're on a team. Now, so that means in agreement with or corresponding. When we're talking about math, in math, congruent means and is used to show that two objects or figures have the same measurement, meaning that two angles have the same degree measurement, or two lines or two segments are the same length. That's what congruent means. So let's look at just a quick example here. So if we have these two segments, segment AB and segment PQ or QP, these are both 5 centimeters long as shown by the diagram. Since they're both the same length, that means that they are congruent. So again, since AB, segment AB is the same length as segment QP, we could say that these segments, or would say that these segments are congruent. Now, if we're using the symbol for congruency here, the way that we would write it is we would say segment AB, again, the bar above it means it's a segment, is congruent to, that's what this symbol means here, it means that they're the same value, to QP. All right, let's move on. So this little graphic here shows kind of how congruency works when you're marking objects, including lines and angles. So when two segments are the same length, we use these things called tick marks to indicate that they are congruent or the same length. So for instance, if we knew that segment AB is congruent to CD, we could just put one mark in each of those. That kind of tells you, like as you work on the problem, or if somebody else was looking at the problem, that you would know that these are the same length. So if AB was 10 meters, then CD would be 10 meters. Same thing down here. Now, when you have multiple segments that are congruent, we just use the different number of tick marks. So here, segment PQ is congruent to RS, so we just put 2 tick marks on there and 2 tick marks on RS to indicate that those two segments are congruent. Now, that's whenever you have multiple congruent segments, you have to use different numbers of tick marks. Angles kind of work in the same way, where here angles we use arc marks. So if angle TUV is congruent to angle XYZ, that means that angle TUV, this angle right here, is congruent to XYZ. It's showing that by just having these one arc marks here. So if this was 30 degrees, this angle right here would be 30 degrees. And then the same thing with including the same number of arc marks. So if two angles are congruent, they have to have the same numbers. So if we have another pair of angles that are congruent, we would just include another arc mark with it to differentiate it from the angles above. All right, let us use this now. So, well, actually, we're going to get into writing congruency statements first. So if we're given the diagram above here, or this picture to the right, and basically we have all of these markings that indicate congruence, we can write down all 6 statements of congruence. So for instance, we can say that A to B is the same length or congruent to DE. So because they have the same number of tick marks there. We could also say that AC, so AC has 2 tick marks on it. DF has 2 tick marks on it. So those 2 are congruent as well. We could also say BC is congruent to EF because they all both have 3 tick marks on there. And then we could talk about the angles. So this angle right here has 1 arc mark. This has 1 arc mark. So angle B and angle E are the same. They're congruent. So we could say that angle ABC is congruent to DEF. Now, this is pretty important. The order of the letters does matter. So notice how ABC, we start at A, then B, then C. We're starting at A, and it has these 2 arc marks here. Then we're going to B, then we're going to C. If we did the same thing in this other triangle, we'd have to start with D because it has these 2 tick marks or 2 arc marks that match up with A's. And then we'd go to E because that's where B and E match up, and then F. So the order of the letters does matter, and we'll talk about more about that as we kind of progress through the unit. We also have the angle BAC has 2 tick arc marks on it, and then EDF has 2 arc marks on it. So those 2 angles are congruent as well. Again, the order of the letters does matter. And then finally, we have ACB has 3 arc marks, is congruent to DFE. DFE has 3 arc marks as well. So all of these angles, these 2 angles are congruent as well. And again, just another reminder that the order of the letters does matter. You should notice how angle A and angle D both have 2 arc marks. So that means you have to be specific with your naming so that it all matches up. So like E and B should go together. So like E is this middle letter here, B has to be in the middle letter. If A has 2 arc marks, that has to match up with D. So if A is first, D has to be first, and so on. All right. Now, we can use congruency to solve problems now. So let's say that in this diagram, we know that DE is congruent to FE. So we want to use that to figure out what the length of DF is, right? So if DE is congruent to FE, that means that they're congruent. So we can put those little tick marks on there to indicate that they are the same measure. So they are the same length, which means that they're equal. So all you're going to do is set these 2 sides then that are represented by expressions equal to each other here. And then we just solve it for x. So if I rewrite this equation, I would subtract 5x on both sides to get 3x. I would add 13 to both sides to get 30, and then divide by 3 and get x equals 10. Then we're trying to figure out what d to f should be. So I'll take my value of x, which is 10, plug it in here, and then get df equals 10 plus 21, which is just 31. Hopefully that's pretty straightforward, I think. So again, if 2 segments are congruent, they have to be equal. So set them equal to each other, and then solve it for the unknown variable, and then whatever they want you to figure out in the problem, use the variable value to do that. All right, now just a couple more examples here. So in this diagram, that says that angle LMN is 116. So LMN is this whole angle right here, 116. It also says that JKM is 122. JKM is this whole angle right here. And then it also says that JNM is 103. So that's what these measures indicate. So this whole thing is 116. This whole thing is 122, or this whole angle, and this whole angle is 103. They want us to figure out what NKM is. So in order to figure that out, we have to use this congruence, these congruency arc marks. So again, 116 is this whole angle right here. So if this whole angle is 116 and both of these angles have the same number of arc marks, it means they're the same. So we just do 116 divided by 2, and that tells us that each of these angles has to be 58 degrees. Next up, because this has one arc mark and this angle over here has one arc mark, this angle over here has to be 58 degrees as well. Because JNK is congruent to NMK. They're both 58. Now we can take this a step further. This whole angle right here, JNM, is 103. And then the piece of it here is 58. So we can figure out this angle is 45 by doing 103 minus 58. This is the example of angle addition postulate that we looked at in the previous lesson. Finally, we could, since these two angles have two arc marks on them, they have to be congruent as well. So JKN is 45, and MNK is 45 as well, or KNM. They're congruent, so they're both 45. And then lastly, we know that JKM, this whole angle right here, is 122. This angle is 45, so that means that this angle right here is 122 minus 45, which is just 77 degrees. Hopefully that makes sense. There's kind of a lot of moving parts. You can rewind as you need to. Let's move on to the next example. All right, this is making use of segment congruency marks. So we want to know what HF is using this diagram to the right. So you notice that HF is really just HG plus whatever GF is. That'd be the segment addition postulate. And then we can use these markings to kind of help us figure that out. First things first is you should notice that B to C, the distance of B to C, is congruent to the distance of E to F and G to F as well. So both of these side lengths, E to F and G to F, have to be 8 centimeters because that's what BC is. Same thing with AH. AH is 11 centimeters and it has these 2 tick marks here. And since H to G has the 2 tick marks, that means that H to G is 11 centimeters as well. And then using the segment addition postulate, we know that the whole line H to F has to be whatever HG plus GF is, which is 11 plus 8, which is just 19. All right, that's it for congruence. I know this might be a little bit of a longer video. Hopefully you're able to kind of fast forward or skip ahead as you needed to. You should be able to complete the first few problems on the assignment. We're going to pause here and then continue with the remainder of the lessons, which should be a lot shorter videos. Thank you.